Welcome class 7 students. I hope you are doing great and enjoying your studies. So I am your maths teacher and from today onwards we are going to start with our maths chapters. We will start with chapter number 1, which is integers. So open your books and so we have learned about whole numbers and integers in class 6. We shall review them here and study various properties satisfied by various operations on them. So let us start with various types of numbers. First one is natural numbers. So counting numbers are called natural numbers. Thus 1, 2, 3, 4, 5 and so on. All these are all natural numbers. Next is whole numbers. So all the natural numbers together with 0 are called whole numbers. Thus 0, 1, 2, 3, 4, 5 etc. are whole numbers. So students, did you know that division facts come from multiplication fact? After that, we have integers. All the natural numbers, 0 and negatives of the counting numbers are called integers. Thus, -4, -3, -1, 0, 1, 2, 3, 4, etc. are all integers. So here we have positive integers which are 1, 2, 3, 4, 5, etc. are all positive integers. Then we have negative integers, that is -1, -2, -3, -4, -5 etc. are all negative integers, and 0 is an integer which is neither positive nor negative. There is no smallest or greatest integer. Let us start with addition of integers. So we have several rules. Let us start with rule number 1. Addition of integers with like sign. That is, if two positive or two negative integers are added, we add their values regardless of their signs and give the common sign of the integer. For example, let us try this with an example. So in this example, we have to add, in first part, we have 14 and 23. So since no sign is written, so since 14 and 23 have no sign in front of them, so that means this is plus 14 and plus 23. On adding these two numbers, this will be equal to 37. And since both the signs are positive, so we will put a common sign which is positive. That means 14 plus 23 will be equal to plus 37. Similarly, if we have -5 and -17. So again we will add 5 and 17. So here we have -5 and -17. So on adding 5 and 17, this will be equal to 22, and we will put a common sign which is minus. So -5 minus 17 will be equal to -22. Or we can write it as 14 plus 23 is equal to 37, and this will be equal to -5 plus -17, which is equal to -20. So now let's see rule number 2. Addition of integers with unlike signs, that is to add a positive and a negative integer, we find the difference between their numerical values regardless of their sign and give the sign of the integer with greater value to it. Again, we will try one example to understand this thing. In this example, in first part, we have to add -45 and plus 26. So now we have -45 plus 26. Since the sign of both the numbers are different, so we will subtract these two numbers. 45 minus 26 will be equal to 19. And we will put the sign of the greater number. Since 45 is greater than 26, so we will put minus sign here. That means -45 plus 26 is equal to -19. Similarly, let's see second part also. We have -50 and plus 38. So -50 plus 38, we will subtract these two numbers. This will be equal to 12. Also here The greater number is 50 and the sign of 50 is minus. So we will put minus here. That means minus 50 plus 38 is equal to minus. So now let's see our next topic, which is properties of addition on integers. So our first property is closure property of addition. The sum of two integers is always an integer. For example, if we take any two integers like 5 and 6, so 5 plus 6 is equal to 11, which is an integer. Similarly, minus 7 plus 3 is equal to minus 4, again which is an integer. Similarly, minus 20 plus minus 5 is equal to minus 25, which is an integer. Similarly, if we add any number to 0, like 0 plus 15 will be equal to 15, which is again an integer. And 15 plus minus 8 is equal to 7, again this is an integer. So that means if we take any two numbers, if we take any two integers, the resultant of their sum will be again an integer. Second property is commutative law of addition. So when two integers are added in any order, the sum always remains the same. If a and b are any two integers, then a plus b will be equal to b plus a. The order does not matter. For example, 6 plus 8 is equal to 14 and 8 plus 6 is also 14. Similarly, minus 3 plus 16 is equal to 13 and 16 plus minus 3 will again be equal to 13. Similarly, minus 12 plus minus 10 is equal to minus 22 and minus 10 plus minus 12 is again equal to minus 22. Similarly, observe fourth part also. So, in commutative property of integers, the order does not. Next, we have associative law of addition. Three or more integers can be grouped in any order to find their sum. If a, b, c are three integers, then a plus b plus c will be equal to a plus b plus c. For example, consider the integers minus 5, minus 7 and 3. So we have minus 5 plus minus 7 plus 3. So here first we will add minus 5 and minus 7. So this will be equal to minus 12 plus 3 will be equal to 9. Now add minus 5 plus minus 7 plus 3. So now we will add minus 7 plus 3, which is equal to minus 4. So minus 5 plus minus 4 is equal to minus 9. So in both the cases, the final result is same, which is minus 9. So therefore, minus 5 plus minus 7 plus 3 is equal to minus 5 plus minus 7 plus 3. Similarly, other examples may be taken up. Let's see one more property, which is existence of additive identity. For any integer a, we have a plus 0 is equal to 0, which is equal to 0 plus a. 0 is called additive identity for integers. For example, 0 plus 8 is equal to 8 plus 0, which is equal to 8. Then in the second part, we have minus 7 plus 0 is equal to 0 plus minus 7, which is equal to minus 7. Similarly, minus 31 plus 0 will be equal to 0 plus minus 31, which is equal to minus 31. Then the fifth property is existence of additive inverse. For any integer a, we have a plus minus a equal to minus a plus a, which is equal to 0. So that means the opposite of an integer a is minus a. The sum of an integer and its opposite is 0. So we can say that additive inverse of a is minus a. Similarly, additive inverse of minus a is a. For example, we have 4 plus minus 4 is equal to minus 4 plus 4, which is equal to 0. So that means additive inverse of 4 is minus 4 and additive inverse of minus 4 is 4. Now let us see subtraction of integers. I hope you have understood all the properties of addition of integers. So now let us start with subtraction of integers. If a and b are two integers, then a minus b is equal to a plus minus b. That is, to subtract b from a, change the sign of b and add it to a. So a minus b will be equal to a plus minus b. For example, if we have plus 4 minus plus 2, so change the sign here. This will be plus 4 plus minus 2, which is equal to 2. Similarly, if we have plus 6 minus minus 4, so change both the signs. So this will be equal to minus 6 plus 4. Now let us start with properties of subtraction. First property is closure property of subtraction. The difference of two integers is always an integer. If a and b are any two integers, then a minus b is always an integer. Second property is subtraction of integers. Second property says subtraction of integers is not commutative. For example, if we have 3 minus 5, so we can write it as 3 plus minus 5, so this is minus 2. And if we find 5 minus 3, so this will be equal to 5 plus minus 3, which is 2. So since minus 2 is not equal to 2, thus 3 minus 5 is not equal to 5 minus 3. Again, minus 4 minus 3 is equal to minus 4 plus additive inverse of 3, which is minus 3. So this is minus 4 plus minus 3, which is minus 7. And minus 4 minus minus 4 will be equal to minus 3 plus additive inverse of minus 4, which will be minus 3 plus 4, that is 1. Here also you can observe that minus 4 minus 3 is not equal to minus 3 minus minus 4. So now our next property is subtraction of integers is not associative. So let us take an example. Consider the integers 3, minus 4 and minus 5. We have 3 minus minus 4 minus minus 5. So first we will solve 3 minus minus 4. For that we will write it as 3 plus additive inverse of minus 4 and minus minus 5 as it is. So this will become 3 plus 4. 3 plus 4 minus minus 5. 3 plus 4 is 7. So this will be 7 minus minus 5. Now we can write it as 7 plus additive inverse of minus 5, which is 5. So 7 plus 5 is equal to 12. Similarly, if we subtract minus 4 and minus 5 now, so the final result will be equal to 2. That means 3 minus minus 4 minus minus 5 is not equal to 3 minus minus 4 minus minus 5. I hope you have understood all the properties. So now try all the questions of exercise 1.1 by. Let us move on to our next topic now, which is multiplication of integers. So multiplication is repeated addition of the same number. For example, 4 into 3 means 3 plus 3 plus 3 plus 3. That is addition of 3 4 times. So this will be equal to 12. Then we have 3 into 7, which can be written as 7 plus 7 plus 7, that is 21. Similarly, if we have 2 into minus 3, so this will be minus 3 plus minus 3, that is minus 6. In the similar manner, 4 into minus 7 will be minus 7 plus minus 7 plus minus 7 plus minus 7, that is addition of minus 7 4 times, so this is minus 28. Similarly, 8 into minus 2 means addition of minus 2 8 times, that is minus 16. We also know that 3 into 4 is equal to 4 into 3 and 3 into 4 is equal to 4 plus 4 plus 4. So thus 4 into 3 is equal to 3 plus 3 plus 3 plus 3, which is equal to 12. Similarly, minus 2 into 3 is equal to addition of minus 2 3 times, that is minus 6. Minus 4 into 7 is equal to addition of minus 4 7 times, which will be equal to minus 28. And minus 8 into 2 is minus 8 plus minus 8. That is addition of minus 8 2 times. Minus 8 into minus 8. That is addition of minus 8 2 times. So this will be equal to minus 16. So from the above pattern, we observe that 2 into minus 3 is equal to minus 2 into 3, which is equal to minus 6. Similarly, 4 into minus 7 is equal to minus 4 into 7, that is minus 28. 8 into minus 2 is equal to minus 8 into 2, which is equal to minus 16. Now let us see some of the rules. So we will start with rule number 1. To find the product of two integers with unlike sign, multiply the absolute values of the integer and put minus sign in front of the product. For example, let us try some examples now. So in this example, we have to find each of the following products. So let us try with first. In this, we have to multiply 6 into minus 5. So we will multiply 6 into 5, which is equal to 30. And put minus sign in front of it. So this will be equal to minus 30. Similarly, you have to try rest of the parts by yourself. Now let us see rule number 2, which says to find the product of two integers with same sign, find the product of their values regardless of their sign and give plus sign to the product. Again, let us try one example. So in this example also, we have to find each of the following products. So let us see the first part, in which we have to multiply 12 and 16. So here you can see that 12 and 16, for both the numbers, the sign is positive. So 12 into 16 is equal to 192. Since both the signs are positive, so we will keep the positive sign for the product also. So that means 12 into 16 is equal to 192. Similarly, let's see one more part in which we have to multiply minus 8 into 14. So one number has negative sign and other number has positive sign. So to find the product, we will first multiply the numbers regardless of their sign. So 8 into 14 will be equal to 112, and since one number has negative sign, so we will put a minus sign here. So this is minus 112. Similarly, we have third part also, which is similar to second part. So try third part by yourself. We will move on to the fourth part now, in which we have to multiply minus 70 and minus 31. So we'll forget about sign for now and multiply 70 and 31. So this will be equal to 2170. And since both the numbers have same sign, so we will put a positive sign here. That means minus 70 into minus 31 is equal to plus 2170. I hope you have understood this example. So now we have properties of multiplication. Let's read the properties one by one. So we will start with property number 1, which is closure property for multiplication. The product of two integers is always an integer. For example, 7 into 4 is equal to 28. So which is an integer? Similarly, 2 into minus 15 is equal to minus 30. Again, which is an integer. Then minus 7 into minus 8 is equal to 56, which is an integer. And similarly, minus 6 into 0 is equal to 0, which is again an integer. Now let us see property number 2, which is commutative law for multiplication. Two integers can be multiplied in any order. For any two integers a and b, we have a into b equal to b into a. For example, 5 into minus 8 is equal to minus 40. Similarly, minus 8 into 5 will be equal to minus 40 again. Also, minus 9 into minus 7 is equal to 63, and minus 7 into minus 9 is again equal to 63. Now we have a third property, which is associative law of multiplication, which says 3 or more integers can be grouped in any order to find their product. For any integers a, b, c, we have a into b into c equal to a into b into c. For example, consider the integers 3, minus 5 and minus 8. So we have 3 into minus 5 into minus 8. So first we will multiply 3 and minus 5. So this will be equal to minus 15, and minus 15 into minus 8 is equal to 120. And 3 into minus 5 into minus 8. So in this case we will multiply minus 5 and minus 8 first, which is equal to 40. And 3 into 40 is again equal to 120. So that means in both the cases this is equal. Therefore, 3 into minus 5 into minus 8 is equal to 3 into minus 5 into minus 8. Similarly, consider one more example. So in this, consider the integers minus 8, minus 6 and minus 5. So we have minus 8 into minus 6 into minus 5 will be equal to, so in this case, we will multiply minus 8 and minus 6 first, which is equal to 48. And 48 into minus 5 is equal to minus 240. And minus 8 into minus 6 into minus 5. So in this case, we will multiply minus 6 and minus 5 first, which is equal to 30. So minus 8 into 30 will be equal to minus 240. So therefore, minus 8 into minus 6 into minus 5 is equal to minus 8 into minus 6 into. Now let us see our fourth property, which is distributive law of multiplication over addition. For any integers a, b, c, we have a into b plus c equal to a into b plus a into c. For example, consider the integers 5, minus 6 and minus 8. So we have 5 into minus 6 into minus 8. So let us solve minus 6 plus minus 8 first. So we have 5 into minus 6 plus minus 8. So here we will solve minus 6 plus minus 8 first, which is equal to minus 14. And 5 into minus 14 is equal to minus 70. And now let us solve the RHS part, which is 5 into minus 6 plus 5 into minus 8. 5 into minus 6 is minus 30. 5 into minus 8 is minus 40. On solving, this will be equal to minus 70. So therefore, 5 into minus 6 plus minus 8 is equal to 5 into minus 6 plus 5 into minus 8. Now our next property is existence of multiplicative identity. For any integer a, we have a into 1 equal to 1 into a equal to a. So here 1 is called the multiplicative identity for integers. For example, 15 into 1 is equal to 15, minus 18 into 1 is equal to minus 18. Similarly, 1 into minus 17 is equal to minus 17. Now next is existence of multiplicative inverse. So multiplicative inverse of a non-zero integer a is the number 1 upon a. As a into 1 upon a is equal to 1 upon a into a, which is equal to 1. So for example, multiplicative inverse of 6 is 1 upon 6. Multiplicative inverse of minus 6 is minus 1 upon 6. So our next property is property of 0. For any integer a, we have a into 0 is equal to 0 into a equal to 0. Now let us try some examples. In this example, we have to simplify. Let us consider the first part, in which we have 9 into minus 14 plus 9 into 8. So let's see how we can solve this part. Here we can see that 9 is common in both. 9 is common in both of them. So we can take 9 common. So this will be 9 into, here we have minus 14 plus here we have 8. So now 9 into minus 14 plus 8. Minus 14 plus 8 will be equal to, since we have two different signs, so we will subtract these two numbers. So 14 minus 8 is equal to 6. And since 14 is the greater number and sign of 14 is minus, so we will put minus sign here. So that means on solving this, we have minus 6. Now we have 9 into minus 6. 9 into 6 is 54. And since we have opposite signs, one is positive, one is negative, so we will put negative sign here. So the final result will be equal to minus 54. In the same manner, you have to do rest of the three parts of this example by yourself now. You have to use the distributive property of addition in all the four examples. And after that, do all the questions of exercise 1.2 also by yourself. So now students, our next topic is division of integers. You know that division is an inverse process of multiplication. So for this also we have some of the rules. So let's start with rule number 1, which says if the dividend and the divisor both are positive or both negative, the quotient is positive. For example, evaluate 98 divided by 14. So 98 divided by 14 is 7. Since both the numbers have positive sign, so the final quotient will also be positive. So this is plus 7. Similarly, minus 48 divided by minus 16. 48 divided by 16 is equal to 3. Now since both the numbers have negative sign, so the final quotient will have positive sign. So this will be equal to plus 3. Similarly, in third part, we have minus 19 divided by minus 15. So 90 divided by 15 is 6. And since again both the numbers have negative sign, that is same sign, so the final quotient will be positive. So in second and third part, we can observe that minus sign of numerator cancelled by minus sign of denominator. Now let us see rule number 2, which says if either the dividend or the divisor is positive and the other is negative, the quotient is negative. Again, let's see examples. So in this example, we have to evaluate. In first part, we have 72 divided by minus 8. 2 divided by 8 is equal to 9. And since one number is positive, other is negative, that is both the numbers have different sign, so the final quotient will be negative. So this is minus 9. In the second part, we have minus 44 divided by 12. So now in the second part we have minus 144 divided by 12. Now 144 divided by 12 is equal to 12. Since one is negative, other is positive, so the final quotient will be minus 12. Similarly, in third part we have minus 69 divided by 23. 69 divided by 23 is 3. Again, since one is negative, one is positive, so the final quotient will be minus 3. Let's try some of the parts for this example. So here we have to find, in first part we have minus 20 divided by 4. Now we know that 20 divided by 4 is equal to 5. Since we have minus 20 divided by 4, one is negative, one is positive, so the final quotient will be negative. That is, this will be equal to minus 5. Similarly, we have second part. So try second part by yourself. Part now, in which we have to divide minus 15 and minus 3. So minus 15 divided by minus 3. 15 divided by 3 is 5. Since both have same sign, so the final quotient will be positive. Minus sign will be cancelled by this minus sign. So this will be plus 5. In the similar manner, try rest of the parts of this example by yourself. Let's see one more example. We have to fill in the blanks. So in first part, we have minus 37 divided by something is equal to 1. So we have to fill in this blank. We know that a number divided by itself gives the quotient equal to 1. So that means minus 37 divided by minus 37 will be equal to 1. In the similar manner, observe rest of the parts by yourself. Now let us see second part also, in which we have something divided by 36 equal to minus 2. So in this we have to find out the number which is divided by 36 gives minus 2. So we will let the required number be x. So we can write it as x divided by 36 equal to minus 2. Or we can say x divided by 36 equal to minus 2. Now since 36 is being divided on the left hand side of the equal to sign, so when we will take it to the right hand side, it will get multiplied. So that means x will be equal to minus 2 into 36. Now 2 into 36 is 72, and since both the numbers have different signs, so we will put minus sign here. So that means minus 72 divided by 36 gives the quotient equal to minus 2. Now in the similar manner, do rest of the two parts of this example. So now let's see our next topic, which is properties of integers for division. So if a and b are integers, then a divided b is not necessarily an integer. For example, 16 and 5 are both integers, but 16 divided by 5 is not an integer. Similarly, in second part, we have minus 9 and 4 are both integers, but minus 9 divided by 4 is not an integer. Now, which says if a is an integer and a is not equal to 0, then a divided by a is equal to 1. For example, 15 divided by 15 is equal to 1, minus 8 divided by minus 8 is equal to 1, and so on. Now let's see point number 3, which says if a is an integer, then a divided by 1 is equal to a. For example, 7 divided by 1 is equal to 7. Similarly, minus 5 divided by 1 is equal to minus 5. Now let us see property number 4. So here in this book 0 is written, but it should be if a is an integer and a is not equal to 0, then 0 divided by a is equal to 0. But a divided by 0 is not meaningful. Now let us see one example. This example says if a, b and c, if a, b, c are integers, then a divided by b divided by c is not equal to a divided by b divided by c, unless c is equal to 1. Thus, division of integers is not associative. Let us see an example for this. Let a is equal to minus 8, b is equal to 4 and c is equal to minus 2. Then a divided by b divided by c will be equal to minus 8 divided by 4 divided by minus 2. Now first of all, we will divide minus 8 and 4. This will be equal to minus 2, and minus 2 divided by minus 2 is equal to 1. Now we will solve a divided by b divided by c, which is equal to minus 8 divided by 4 divided by minus 2. So in this case, we will divide 4 and minus 2 first, which will be equal to minus 2. And minus 8 divided by minus 2 is equal to 4. So as you can see, both the results are different. Therefore, a divided by b divided by c is not equal to a divided by b divided by c. However, if a is equal to minus 8, b is equal to 4 and c is equal to 1, then a divided by b divided by c will be equal to minus 8 divided by 4 divided by 1. So we will divide minus 8 and 4 first, which will be equal to minus 2. Divided by 1 will be equal to minus 2. Similarly, we solve a divided by b divided by c. So this will be minus 8 divided by 4 divided by 1. Now 4 divided by 1 is 4. And minus 8 divided by 4 is equal to minus 2. So in this case, both the results are equal. So that means if c is equal to 1, then the result will hold, and if it is not equal to 1, then the result of associativity will not hold. Now let us see property number 5, which says if a, b and c, if a, b, c are non-zero integers and a is greater than b, then a divided by c is greater than b divided by c if c is positive, and a divided by c is less than b divided by c if c is negative. Now let us see some examples. So in first example, we have 27 greater than 18 and 9 is positive, where a is equal to 27, b is equal to 18 and c is equal to 9. Therefore, 27 divided by 9 is greater than 18 divided by 9. Similarly, if 27 is greater than 18 and 9 is negative, so here a is equal to 27. So where a is equal to 27, b is equal to 18 and c is equal to minus 9. So therefore 27 divided by minus 9 will be less than 18 divided by minus 9. I hope you have understood all the properties now. That we are at the end of this chapter now. I hope you have enjoyed today's class and understood all the concepts. We will meet again in the next class now. Till then, practice as much as you can and take care of yourself.